I was the one that did it, but you know, whatever. Okay, so oxidation is very important in our discussion of nomenclature in both naming things and making compounds. The last thing we did yesterday was we looked at the chemical Fe2O3. Now obviously this is iron oxide. But there's a lot of different iron oxides. And since iron is in the D block, we need to tell the audience which iron we're talking about. So, quick review. Group 1, what is the charge of everything in group 1? Plus 1. They have one extra electron. They're going to lose it to complete their octet, and it's going to be plus 1. Everything in beryllium's group will have what? Plus 2. Boron's group? Plus 3. Carbon's group? Plus or minus 4. Nitrogen's group? Minus 3. Oxygen? Minus 2. The halogens? And of course the noble gases are 0. So, in order to figure out which iron we're talking about, we have to use this very important rule that the total oxidation of all of the compounds, of any compound, must be 0. In other words, the positive cation charge has to balance the negative anion charge. They have to balance out to become 0. So, we might look at oxygen and say, well, I don't know what iron is, but I know what oxygen is. And oxygen, being in group 16, has a charge of what? Minus 2. So oxygen's minus 2. How many oxygens are present in iron oxide? In this one there are 3. So negative 2 times 3 means the overall negative side is what? Negative 6. If the negative side is negative 6, what must the positive side be? Plus 6. Okay. Again, rule number 1, the positive side has to exactly balance the negative side. Now, if the positive side is plus 6, and there are 2 irons making up that plus 6, then each iron must be what? Plus 3. So this is iron 3 oxide. Yes?
Is there any time where I'll just, never mind,
All right. Okay. So, 2 rules with oxidation. First rule is they have to balance out to be 0. Second rule is if there's nothing to balance out, if it's a free element, it's going to be 0. Like N2, Cl2, O2, H2, those are 0. Question?
What if there's like another element out there with
Okay. What if there's another element? We're going to try to just do binary compounds. A binary compound is one positive thing, one negative thing. Every now and then, in a homework assignment or looking online, they'll squeeze in another one. But we're just going to focus on this class in binary, plus, negative. Binary means 2 things. Okay. Give me a thumbs up if you're with me so far. Good. Okay. So look at the oxidation numbers. I apologize, the projector is really crappy. You won't be able to see it, but I'll try to read them to you. This is lithium plus, magnesium 2 plus. This is sulfur in calcium sulfide. This is chlorine in silver 1 chloride. This is aluminum in aluminum fluoride, and this is oxygen. So scribble these guys down, and then scribble down what you think their oxidation charges are. Don't make it more complicated than it is, which is not very complicated. Yes?
If you would be naming that, what would it be? Iron Roman numeral 3 oxide?
We could shorten that down to just iron oxide, or iron 3 oxide. It's red, iron 3 oxide, because the iron 3 is the iron that's plus 3 in the compound. Iron 3 oxide.
So like try
do we not say iron trioxide? Because it's a metal. We only use the mono-di-tri when we have two non-metals. Carbon dioxide, boron trifluoride. Only when there are two non-metals do we use the mono-di-tri tetrapentahexaoctanonadecade. So when you predicted the oxidation of these 6 things, lean over to your neighbor and show them your glory and see if your glory equals their glory. Where? It's an F. ALF3. It looks good on my screen. Yes.
If you want to write like 2 plus, would it be 2 plus or plus 2?
Doesn't matter. I've never seen a standardized way. Some resources will say plus 2, some resources will say 2 plus. There's no standardized way. Yes.
What would the charge be if you got like the manganese and manganese?
Manganese? You would have to, it's an excellent question. You would have to determine what it's bound to. Since manganese is a D block metal, you have to look at whatever anion it's attached to, and then work backwards.
What does that mean? What anion?
Okay, so let me give you an example. Yeah. So if you have manganese Cl3, okay, obviously this is manganese chloride, but since it's manganese, we need to basically say which manganese. So we look at the chlorine and we'd say, well, the chlorine is -1 each. So you have a -1, a -1, and a -1. If you have 3 chlorines, that makes the manganese what?
Positive 1, positive 1, positive 1.
But there's only one of them.
Just positive 1 then? Positive 3.
Positive 3. So this would be manganese 3 chloride. Does that idea make sense?
Yeah.
It's kind of like that arithmetic you learned in 5th grade, where it's like m plus -3 equals 0.
Does it always equal out if you're bonding together? So like you can just kidding, never mind.
Just full of jokes. That's a funny joke. Okay, so yes, rule number 1 for the oxidation is the overall compound must balance to 0. Okay, is that what you got? Lithium +1 is just +1. Manganese 2 plus is just +2. Sulfur is -2.
Oh,
Chlorine is -1. Aluminum is +3. And oxygen, because it's all by itself, is just a big fat 0.
so wait, you were just trying to find
The oxidation of the lit up atom, yeah.
Wait, why did you get 0?
oh, I thought you were trying
Because oxygen's all by itself. Yeah. Chlorine, since chlorine's -1, that makes silver +1. Calcium's always +2 because it's in group 2. Fluorine is -1 each, so -1. So 3 minus 1 to cancel +3. 3.
Oh, there's none.
Chlorine's -1. There are 3 of them
Oh, we're
to
trying
balance
find,
out a little.
Oh, we're trying to find the white.
Oh, and if you found the blue, great. It's
Yeah, I was just trying to balance.
excellent. Okay. Other questions about this? Give me a thumbs up if you're ready to do some practice. All right. So, this is what I need from you. I'm going to show you 5 compounds. What I need you to do is identify the oxidation number of each thing, positive and negative, and then when you're done with that, name them. So, we'll do the first one together. So, you have 5 compounds here. You need to determine the oxidation of each of the ions, and then name them. Lithium is in group 1. What's its oxidation? +1. Fluorine is in group 17. What's its oxidation? -1. The 2 special cases for naming are if you have 2 nonmetals or if one of them is a D block. Do you see 2 nonmetals? No. Do you see a D block? No. So no special naming. What's the chemical going to be called? Lithium fluoride. Okay. So do the other 4 on your own.
Is that all you do?
Okay. So questions about this stuff? Give me a thumbs up if you're ready to move on. Okay. There's only one thing left to learn in nomenclature, and that is something called polyatomic ions. What does poly mean?
Many.
Many, or multiple, yeah. So these are ions made up of many atoms. They work as a block. They move together as a block. So they don't break up. They're stable units, but they are made of more than one thing. Now we're still learning binary compounds. Only now, one of the things, either the cation or the anion, is a block of multiple atoms. A polyatomic ion. There are hundreds of polyatomic ions. We're going to use 7 of them. We're going to learn 7 of them. And if you remind me on tests and quizzes, we will write them on the board so you don't even have to memorize them. I strongly recommend you have your notes always with you when you're doing work. You can always look up, what is sulfate? And so on and so forth. Okay. Are you ready for them? No. Okay. Great thing about polyatomics, they don't get any kind of prefixes or changes at all. You don't change their name. They don't get any prefixes, no dis, tris, monos, tetras, anything like that. And they're a single block. They always have the same charge. So, yes?
What do you do if you, do the lanthanide actinides count as a D block?
Yes. Yes. And we'll never use those in this class, but later on when you move on to more advanced chemistry, yeah, you will have lanthanides and actinides, and they just act just like a D block. Uranium-3 oxide. Okay, so first polyatomic, nitrate. Nitrate. Nitrate has a -1 charge, and it's made of NO3. Yes.
What makes it a polyatomic?
I'm sorry?
What makes it a polyatomic ion?
Who can answer that? What makes it a polyatomic ion? Yeah, it's made of a nitrogen and 3 oxygens, multiple atom ion, polyatomic ion. Okay, the next one is also -1, and it is hydroxide. It's written backwards because they want to make it O instead of HO. I don't know why. I wasn't there at the meeting. But hydroxide is OH minus, 1 hydrogen, 1 oxygen. and has a -1 charge. The next one's also a -1, and it's a really big polyatomic with lots of things, and it is acetate. C2H3O2. -1 charge, acetate. So C2H3O2 is acetate with a -1 charge. The next two have a -2 charge, something we're going to be using a little bit later on. Sulfate, SO4 2-. Yeah, it's really, okay, whether you do 2- or -2, it does not matter. It really doesn't. I do it both ways because there is no standard way. You can do 2- or +2. There's no standard proper way. The next one's also -2. Carbonate. Calcium carbonate. Hydrogen carbonate. Sodium carbonate. There are so many carbonates. The sixth one is really big, and it's -3, and it is phosphate. A phosphorus and 4 oxygens. Pretty good sized polyatomic. Now these are the 6 negatively charged polyatomics, and they're going to be joined by 1 positively charged polyatomic. But before I mention that, I want you to see if you can see the pattern. If nitrogen's all by itself, what do we call it? Nitride. With oxygen, it becomes nitrate. If sulfur is by itself, we call it sulfide. With oxygen, we call it sulfate. Carbon by itself is carbide. With oxygen, we call it carbonate. Phosphorus by itself is phosphide. With oxygen, we call it phosphate. So you see the pattern? There's a whole bunch of 8s out there. All of them meaning with oxygen. Okay. But understand that we only care for you, we only care about these. Nitrate, acetate, sulfate, carbonate, phosphate, and of course hydroxide stuck in there too. Now, the one positively charged polyatomic is ammonium. Apologize for the projector. Looks great on my screen. Ammonium, NH4+. All right. Questions about these polyatomics?